This module covers low-level APIs and some iOS/Android specific details. I don't aim to teach Objective-C or some core concepts of Android development. You don't necessarily need to know these things, but they would help. It's important to notice that the code in this module is fresh and complete. It's here as a porting reference. Since this is pre-alpha level code, it should be treated as such. I've discussed low-level native interfaces and third-party library integrations before, but I never did it for an API as complex as the camera API. Arguably, the maps support is harder, so developers could have used it as a reference. My chief motivation in doing this module is building the CN1lib itself. Low-level camera access has been a wish list of ours since we introduced Z-ordering of components. As such, the tutorial is an afterthought. The first step of implementing a CN1lib is looking for available APIs on both sides and sometimes surveying the work done by other cross-platform tools for inspiration. In this case, other tools don't offer something as comprehensive, so I didn't spend too much time on that. Android's native camera API is a mess, and at some point Google just threw the whole thing out and replaced it with Camera 2. If you want to support older devices, you need to support both APIs, and there's a lot of nuance with permissions, etc. I didn't want to use the native Android API as is, and started checking for options. Two open source camera APIs stood out, and CameraKit Android looked like the best option. Normally, this is the place where I would go over the Android API and go over the iOS API and try to find common ground. Instead, I chose to skip that and just write the Android implementation, then think about the iOS implementation after the fact. My reasoning was that CameraKit already spent a lot of time designing an abstract API. It makes sense to follow their lead. I'm not a camera expert, but they already dealt with user requirements and design issues. This would make the Android implementation trivial, and if something doesn't work on iOS or elsewhere, we can create special cases for that. I didn't build a CN1lib. I started with an app that uses native interfaces. Apps I can debug, unlike a CN1lib. Once the app was done, I just copied the sources into a new CN1lib project and created that. So without further ado, let's dive into the portable portion of the code. As I mentioned before, I decided to model the API based on the Android Camera Kit API, which is mostly exposed in the Camera View class. You can see in the Camera View project. Camera View is a big class with a lot of UI code, so I wanted to distill the API calls within. I searched within the class for public methods and isolated them. I then created a new native interface within com.codename1.camerakit.impl. The one method that's a special case that didn't exist in the original is peer component getView. This is a method that returns the preview for viewing the camera. In the native code, it's the actual camera view class, but in our case, the native interface hides that. This method returns the camera view in the native code. Camera view has a method, getCameraProperties, which returned an object called CameraProperties. That object contained two fields, horizontal and vertical, viewing angles, which I just mapped directly. In retrospect, some of these APIs like toggle facing flash, is facing back, front, should have been implemented in the Java side. The API already used ints for constants, so this was pretty easy to translate into a native interface. These two rely on event listener code. I'll elaborate more on that soon. These were originally preview and capture size. They returned a size object which was just width and height in a class. As you can see, the translation was mostly easy, and other than a few methods that returned objects, everything was really smooth. I did gloss over some APIs I chose not to implement within the native interface. You will notice all of these methods have one thing in common: callbacks. We can't pass a callback into the native interface, so all of these APIs can't be implemented in the native interface. We can implement them in the high-level abstraction though, and I'll get into that soon. But before we go there, I did mention the constants from the native API. They are implemented in the CameraKit class in the native project. I had to implement our own constants, which I did using an interface. You'll notice that this is copied from the Android version, and so values returned from there should automatically work for us on Android, which is pretty cool. Never expose a native interface to a user. It's a recipe for disaster, as things might not work as expected. Always wrap the native interface in a regular class, as that allows for fine-grained control. It lets you change the native API and move forward while keeping compatibility and simplicity. So the next order of business was the decision of how to encapsulate this functionality. For that, I created the CameraKit class, which abstracts this native interface. We implement the constants interface, so we'll have easy access to them. The native interface instance is shared between the methods of the class. This is a singleton. It's not how the native API works, but it's much simpler, and we don't need anything better. We use this list to send camera events to the user of the API. I'll discuss that further soon. iOS strips out unused code, which can cause callbacks to fail. We need to trick the iOS VM into thinking that some code will execute. iOS needs a build hint. We can just inject it into the build hint list if the user didn't declare it. We review the build hints if the iOS.ns camera usage description isn't declared. We add it. Notice that this will work only on the simulator. I called this create even though it's more like a getInstance method. While the CameraKit won't work on the simulator, I can still bind functionality to it. In this case, we do two things in the simulator. We registered the required build hint if it isn't there already. We invoke all the callback methods. Notice that this code will never execute, but our iOS VM can't detect that because this is for iOS isn't private. Without these calls, the iOS VM would strip out these methods and the C code that invokes them wouldn't compile. If the native interface is supported on this device, then we can return the instance of this class, otherwise we return null. There is a lot to digest here. Luckily, this was the hardest part. The rest is verbose, but it's far simpler than this. Most of the class looks like this. We delegate the calls to the native interface to keep that code hidden. Nothing interesting. There are a few interesting methods within the class, so I'll address them here and skip these boring calls. Toggle facing is in the native interface, but instead of implementing it in iOS, I chose to implement it in the camera kit and ignore the native interface. The same is true for toggle flash. I'm sure I could do this for several other methods and simplify the native interface layer. The add remove listener code just modifies the list of listeners. Notice I trimmed the code a bit so it would all fit in one slide. The fire methods are invoked internally to send events to the listeners. Since the native code invokes them, they might not be on the EDT, and so they recurse via call serially to move the context into the EDT. The event dispatch logic is identical for all the fire methods. It's just a loop over the listeners and a method invocation. The rest of the listeners follow the same semantic for updating a video result or an image result. So, who invokes the fire methods? I deprecated this and the native interface so developers won't use them by mistake. This class is for internal usage only. All three events are handled in the same way through the fire method. Notice the different types of arguments to the constructors. We'll discuss the complexities of them in the iOS port. The final two missing pieces are the listener interface and event class. Both should be pretty obvious, so I won't list them here. You can check out the project source code if you are curious.